All right, on today's episode of Python Papi, we're back inside our TensorFlow course, and today we started the process of building our CovNets modules. Let's have a look at what we went over this morning. As you recall, yesterday I did bring over a bunch of inputs and a bunch of code from previously that I thought I would need, which I didn't end up needing was okay, but I did keep the inputs because we did need some of the inputs or a lot of the inputs. The only thing we needed to do was specify the image size of 224. So let's pick up where we left off. In order to create our convolutional neural network, we're going to make use of the sequential API, which we built earlier. So this is something that we built earlier. We're just going to bring it over here and modify it. And then we would define our input layer or input shape is 224. And we would define it as an image size by 3. And from there, we would have the normalizer. Next, we have our Cov 2D layer. We will only be using the filters, the kernel size, the strides, the pattern, and the activation out of that, not the entire parameter spectrum. We will put the tf.caress.layers.cov, supposed to be cov, 2D, right after the input layer as our normalizer. We want 6 filters with a kernel size of 5. Our stride will equal 1 to indicate a stride of 1 for both width and height, as I specified to you earlier how that works. And finally, we will set our activation equal to sigmoid to indicate that we are replicating the Linnet architecture. From the Cov 2D, we have a max pooling layer. And looking at our documentation, this is the format for our max pooling. We have the ts.caress.layers.maxpool2d, pool size, strides, padding, and a data format. We want a pool size equal to 2 and a stride of 2. Next, we can simply copy and paste the Cov2D and max pool 2D to use for our next set of feature maps. And we can add a space between the copy and the pasted additions. The number of filters in our new feature map is 16, but everything else remains the same. Also, the max pool 2D remains unchanged. So the max pool 2D is going to get copied and pasted, and it's going to stay exactly the same. The only thing we're changing out of the Cov 2D is going to be the filters, which is 16. So we went from 6 to 16. Next, we will move on to our flatten layer. The flatten layer is in charge of converting everything into a 1D. And from the flatten layer, we now have a dense layer, which we have already seen. Next, we will add 2 more dense layers. Now we'll make sure that as we create the final dense layer, that it has an output of 2 neurons, since we are dealing with a binary classification problem. And this is the model that we come up with after we put all of that into effect. See, we have our ts.caress.sequential. Our input layer specifies in our image size by 3. This is 224 by 224 by 3. Then we have our Cov 2D, which is the filters is 6, kernel size 5, strides 1. You see it's one single digit, meaning we want the stride to be 1 for the width and height. Then have our pattern equals valid. As you remember, the valid equals there is no pattern, and have an activation of sigmoid. Then we have our max pool 2D, pool size of 2, like I specified. Stride of 2, it's a single 2, so you know what that means already. Pattern equals valid, so you know what that means already. Then we copied and pasted this down here, and we moved everything down. As you can see, the only thing that changed out of the Cov 2D was the filters. We went from 6 to 16, and with the pool size, stayed exactly the same. Then we have the flatten function that we ran to flatten everything out into a 1D. And then this is our dense layers. You have 1,000, 100, and then a 2 for the neurons that we specified earlier. So I'm going to go ahead and run this. I don't know how long it's going to take. It is a lot of information that we have to get through. I did run it previously, and I didn't actually get to see the flattened version of it. It was saying that it was trying to allocate too much memory for my laptop. So I guess I have to clear some stuff up to get that going, but everything else works smoothly, and you're going to see the information being processed and compiled. But yeah, everything went smooth this morning. We're going to save that. And we got the dense layer information from, as you recall, we were doing our malaria CovNets. What we left off with, that comes from this information here. I'll see if I can find it really quickly. Yeah, so you see we have 1,000 layers. And finally, well, this one was 200. Maybe it's supposed to be 100 here. So 100 neurons, and then we went down to our 2 neurons. So that's where we got that information from for our dense layers. Let me leave it at 2, because maybe it was 2 for a reason. I'll go back and check it for sure. So that's where we got our dense layer information from. And it looks like everything did compile. Let me move it up for you so we can have a look at what we have here. So yeah, see, it looks saying that the allocation of, yeah, it exceeds 10% of the free system memory. So maybe I have to free some memory space up to actually get those that flatten 1D to actually get compiled out to the system. But everything did work smoothly other than that. And you can see this is what we have here, our layer, our output shape. Why did I move that sideways? Let's get that going. So our curve 2D is none, 220 by 220 by 6, 456 parameters. Our max pooling 2D, none, 110, 110 by 6, 0 parameters. That gives us 2,416 trainable parameters. Now our curve D1. So this is the first one before we copy it and paste it. You got it flattened out, and you can see this was the 44,944, 0 parameters. Dense layers, dense layer, dense layer 202. Overall, we have 45,048,174 trainable parameters with 0 non-trainable parameters. So after all of that, this is how many trainable parameters we have out of our whole model after going through everything. And again, I wish I could show you the flattened version of it like the instructor had, but I probably have to free up some space in my system so that it can get allocated and it can actually compile properly. But yeah, this is what we are so far. So we just now diving into building our Carbonets modules, and this is what we are so far. So everything is working smoothly. All of our inputs work smoothly. All of our coding went smoothly, and everything is moving right along. But we will pick it up tomorrow, and of course, I will keep you guys posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.